Which compound in each of the following pairs of ionic substances has the most exothermic lattice energy? So lattice energy can be described as negative K, which is a constant, times Q1, Q2, the product of the charges of the ions, over the distance that separates those ions. So there's if the lattice energy is more negative, then the compound is more stable. So there's two factors we're gonna consider. Number one is the charge of the ions. The greater the charge of the ions, the product of the charge, the greater the lattice energy is going to be. Now the second factor is going to be the size of the ions themselves. The smaller the ions are, the closer they'll be able to get, which will also lead to a greater lattice energy. All right, so let's take a look. And by the way, we're not going to use the actual charge of the electrons or protons. We're just going to use integer values because we're not actually calculating lattice energy. We're just comparing between the pairs of each compound in the pairs. All right, let's take a look at A. The anions are the same, so we'll have to get our answer considering the difference in the cations. Lithium and cesium are both group 1 metals, so lithium and cesium are both going to lose one valence electron, and their most stable ion will have a 1 positive charge. All right, in other words, the numerator for both these compounds are going to be the same. All right, 1 times 1 versus 1 times 1. So we'll have to consider which one has the smaller radius. Lithium, because it's higher up on the periodic table than cesium, is the smaller ion. And since lithium has a smaller ion, a smaller radius, lithium fluoride will have the greater lattice energy. It'll be closer to the fluoride ion. So the answer to A is lithium fluoride. Let's move on to B. Here the cations are the same. So to find the answer, we'll have to compare the anions. Bromine and iodine are in group 17. So they have 7 valence electrons each. All of those elements in group 17 will have the most stable ion with the charge of 1 negative, because they'll want to gain one more electron to achieve the octet rule. All right, again, we have the same numerators. All right, sodium having a 1 positive charge, bromine and iodine, bromide and iodide both having 1 negative. So we'll have to now, again, look at the size of the ions. Now, because bromine, or rather bromide, the ion, is higher up on the periodic table, it is smaller. So bromide will be able to be closer to the cation than iodide. So because of that, it's going to have the greater lattice energy. Again, the smaller the radius of the ion, the larger. So you can see that mathematically here. The smaller the denominator, the larger the overall value. All right, let's move on to C. Again, we have the same cations, so we'll have to compare anions to get the difference in lattice energy. Now here the charges are different. So chloride, which comes from chlorine gaining an electron, is going to form a 1 negative charge. And then oxide, which is oxygen, once it gains 2 electrons, will have a 2 negative charge. All right. So for barium chloride, we have the Q's are going to be, actually barium is going to have a 2 positive charge as well. 2 positive times chloride, 1 negative, versus barium oxide, 2 positive times 2 negative. So you can see the Q's are larger, the charges are larger in barium oxide, therefore they will have greater electrostatic attraction for each other, and that will lead to a greater lattice energy. So that's a more stable compound. Let's move on to D. Now we haven't learned these polyatomic ions yet, but that's what that is. So their anion here is a polyatomic ion, so and they're the same. So we'll have to compare the cations. Now sodium is a group 1 metal, and calcium is a group 2 metal. So sodium is going to have a charge of 1 positive once it loses its 1 electron, and calcium is going to have a charge of 2 positive once it loses its 2 valence electrons. Right? Sodium is here, and calcium is here. So even though calcium is bigger than sodium, the charge has a greater effect on the lattice energy than the radius. So calcium sulfate is going to have the greater lattice energy. And by the way, sulfate has a 2 negative charge. We'll get to that in our next chapter. Alright, so calcium, because it has the greater charge, will have the greater lattice energy. Alright, let's move on to E. E, the cations are the same. They're both potassium. So now we'll have to compare the anions. And those charges are different. So fluoride is an anion with a 1 negative charge. And oxide is an anion with a 2 negative charge. So again, the higher the charges are, the greater the lattice energy. So potassium oxide will have the greater lattice energy. All right, and finally, let's do F. This time we're both the cations and the anions are different. So let's compare the cations first. Lithium and sodium are both in group 1 metals. So lithium and sodium are right there. Now lithium is smaller than sodium. Otherwise the charges are the same. So lithium has a smaller radius than sodium. Now let's take a look at their anions. Oxygen versus sulfur. Oxygen is smaller than sulfur. So again, that also has a smaller radius. So lithium, this is for lithium oxide. Because both those ions are smaller and the charges are the same, the charges for both of them are 1 positive and 2 negative for both of them. Right? And for sodium sulfide, it's also 1 positive charge on sodium and sulfide 2 negative. But it has a bigger radius. So this is going to be our answer. Lithium oxide will have the larger lattice energy because the radius is smaller for those ions.